So we noticed that the graph of function arcsine looked like a piece of a function sine that was bounded in between of negative and positive 1 on the x-axis. So that's arcsine, which we call it as a sine inverse function. And on the y-axis, it's in between negative pi over 2 and positive pi over 2. So that's a domain and a range of that function. So it's just one little piece, which is indeed a little bit unusual. And the reason again is because if you look at the function sine that continues more and more to the left and to the right, taking the mirror image of it through y is equal to x line will give us the wiggly thing that goes more and more up and down. And this is not going to be a function because of a vertical line test that will keep on intersecting it again and again. So there are plenty of vertical lines that keep intersecting it. So that's why we had no choice but select only one piece. So it'd be called as a function, because if you start to continue, there will be possible intersections with vertical lines. So it is restricted. I guess that's pretty much all we can pull out from the graph of function inverse sine. And the key idea was to realize that this is angle. So whenever they talking about inverse sine, they really mean angle that has sine equal the particular number. So I guess to make this a little bit more clear, I can do problem like 24. So again, this is still section 1 of chapter 7. So when I look at exercise 24 with inverse sine to find, and this is a inverse sine of a negative square root of 2 divided by 2, then what I do is find the angle. Such an angle that sine of this angle is equal to negative square root 2 over 2. In other words, I need to look at the y coordinate, which is a sine, and find when it is negative square root of 2 divided by 2. For what particular point on a unit circle. And it turns out that I must select points from the right half of it, which is lying in between minus pi over 2 to plus pi over 2 angles, because that's our definition that we just saw here. So on the right side, between minus and plus pi over 2. So this will be the angle that has to do something with 45 degrees, but that's actually going to be a negative 45 degrees, again, because it's in between of negative pi over 2 and a positive pi over 2. So to write this with radians, I need to put as pi over 4. In other words, if you decide to check this out, then plugging in negative pi over 4, taking its sine, you will get what you need. And that's why the angle here is negative pi over 4. So I guess that's one of the ways to do this. One can say, Alex, but how do you know that 45 degrees will correspond to this square root 2 over 2? Well, for that matter, I prepared the picture of a last page. Remember that old favorite unit circle that we worked with in the previous chapter. So negative square root 2 over 2, which is going to be exactly the sine of angle, and that angle is not 7 pi over 4. Let me get it a little bit more straight. It's kind of wiggly. So, oh, question is, what's the answer? The answer is right here. This is negative pi over 4. Let me highlight it a little bit better, make it look nicer so you better see this. And then it's negative pi over 4. And what I'm doing right now is double checking it. So just show you how you could get this found using that unit circle. So notice that your angle is right here, because again, it must be in between of pi over 2 and negative pi over 2. So this is negative pi over 2. But what they have on the unit circle is so-called caterminal angle that has same exact ending and started sides, but it always goes counterclockwise. But from definition of arc function, it has to be with a negative sign. So this pi over 4 is going to be not 7 of them, but take from 2 pi, which is same as 8 pi over 4, 1 pi over 4 off. So you go by negative pi over 4, and that's how you get 7 of these. But the answer is pi over 4, of course, because it must be within the range of a function arcsine. We also used calculator last time. So I want to refresh your memories on these as well. So where is our favorite scientific calculator? That's Desmos, right? The first choice. So let me put in it the arcsine function of that negative pi over 4. So to get to the arcsines, they have to go to the functions. So I guess that's the third way to verify it. Let's see, do I have to do it third way? You don't have to do it at all. But the point of story is I'm showing you either way how you can do it, because I know that this arcsines, those inverse functions, are not really very pleasant. But to be honest, this is something that you can do with a calculator, and that's what I'm showing to you right now. So I'm gonna now go back to the main menu, because now I need to enter my numbers. I need to be careful. I need to put my cursor here right next to it, and then go with a minus pi divided by 4, and that should give me exact same result, but in terms of radians. So if you decide to see if indeed this is gonna, well, I need to put not pi over 4, sorry, I got carried away. Square root 2 over 2, right? Our exercise was actually here, right? Find the inverse sine of square root 2 over 2. So I better put whatever it is, because otherwise, of course, it's not going to be the same. So square root 2 divided by 2. And here's my answer, some negative number of radians. If I remember, you can jump between radians and degrees. So you can see that it's minus 45 degrees indeed. Or you could see that if you divide it by 4 number pi, it'd be exactly the answer, negative pi over 4. So someone asks, is that the answer? Yes, yes, of course it is the answer. So negative pi over 4, one can say, but what's this? 45. Well, jump to radians and you will see approximation. See, this advantage of this to be done by a calculator is that you don't really see it in terms of letter pi, because it is divided by 4 and it is approximated as 3.14, right? And even farther than that. But yes, the calculator way is a possibility to work out these problems, but the textbook really likes you to do it the way they want, because in the next section, actually, one exercise is going to have some variable letters, then you just won't be able to get the answer on a calculator because of that variable. Because if you plug in sine x, then, well, what can you get? Just not a number. Calculator needs particular numbers. So I guess the way to go is just to practice and to get used to this. And today's plan is to practice more and more. And another function that appears here is a arc cosine, because last time we done pretty much all of the exercises with arc sine. So today I'd like to practice doing pretty much same thing with a function called arc cosine. So I'm looking for its graph. It should be someplace. I think I missed it. By the way, I updated that YouTube channel. So I had lectures that we had up to date placed on the YouTube. So this way you don't have to look for them. Moreover, some of these first lectures already disappeared from Zoom simply because our college pays only for 30 days for the file to be on Zoom for that recording. So that's why I had to transfer the new set of recordings on that YouTube. So this way you will have them available. I was sending you this link a few days ago, so I can always resend it to you again. It should be in your emails. And advice is just save that YouTube channel. It's in the one single folder, everything, so you can easily get access to those lecture recordings. I think it'd be pretty helpful, especially to do homework, because for homework you can do same exercises that done during the lectures, like problem 24, for example. So here's another function kind of similar to arc sine, and this will be a function called arc cosine. It's also just one wiggly piece, but now its range a little bit different. Its domain is still in between of -1 and +1, just like for function cosine, its range, but in between 0 and pi. So this is the graph of arc cosine, another restricted little function. It is indeed little, and you can see the graph, how it's being produced up here on that picture. So the blue graph is arc cosine that is inverse of function cosine. So they're inverse functions, and we already visualized that fact by noticing that if you apply the cosine inverse to cosine or sine inverse to sine, then you should have same exact number, but under restriction of range, and I guess that's the place to watch out. So we did it last time with a sine. Today I want to do the same thing with a cosine, and looks like there is a tangent here also. Well, we'll tackle it next time. So how about if I try exercise with arc cosine now? So let's say problem 23, one of recommended exercises is here. So we have arc cosine to find. And arc cosine is an angle. So for the arc cosine of this negative square root 3 divided by 2, once again, I'm going to look for the square root 3. I'm going to look for the angle with a cosine equal to square root 3 over 2. So question is cosine of what angle? Is a negative square root 3 over 2. And I just have to recall that this is pretty much same as negative 1, because negative 1 is here. Root 3 over 2 is almost there. So it gives us a little angle up here. So the actual angle I need is going to be that one. And the question is, what is that angle? And all of these relate to either 30 multiples of 30 degrees or multiples of 45 degrees. In other words, if I break this into 3 pieces and then 3 more, I'm going to get like 5 of these pieces, and that's going to be 5 times 30 or 150 degrees, which is in terms of radians, and the answers are usually given in terms of radians. Sometimes people say, Alex, if I give you answer in terms of degrees, what's going to happen? Well, I will understand it. I will accept it. But in the textbook, they always give answers in terms of radians. So since this is a pi divided by 6 pieces, pi is a half rotation. So I take 5 of these little pieces. So it'll be 5 over 6. And this is our answer. That's our angle. 5 pi over 6. Please notice that this is the angle that we have in the range, because our range runs from 0 to pi above. So 5 pi over 6 will be probably someplace here, because I take pi and multiply it by 5 sixes. So it's a little bit less than 1. 6 sixes is 1. So 5 6 less than 1. So it is within range, and we're good. So we got the answer. They say, what if I take the calculator? Would that work? Yeah, we can take a calculator and see, because using technology never hurts, I guess. So you can go again to functions, right? Go the cosine inverse. We just used inverse sine, and now this is inverse cosine. So this be going back to main, and I need to put a negative square root 3 divided by 2. So I just want to make sure I enter it carefully. I want to get out of square root, because otherwise it'll be 3/2 inside the square root. So if I try degrees, you see I just clicked between radians and degrees, and I got 150. But again, I guess it'd be a good idea to actually see that this is same as a 5 pi over 6 by, well, just taking 5 pi divided by 6 and compare with the number above and see it's identical, right? So it is really 5 pi over 6. But again, if someone says it's 150, I would agree because it is same as 150. Why wouldn't I say this is not correct? So looking at the exercises here, the answers are given in terms of exact value, which actually means for them to put 5 pi over 6 rather than the decimal that calculator gives 2.61, because you're going to cut it at some place, put dot, 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 and that's, they say, is not exact. But again, by just showing you the trick, you can put 150 degrees and that's it. So it'll be exact. But anyways, let us see. How about problem number 29 with something that is actually more common, because dealing with these specific numbers like square root 2 over 2 or square root 3 over 2, that's pretty rare. In the real life, we have all kinds of numbers around us. So something like arc cosine of 7/8 is definitely more likely compared to something like square root 3 over 2. And this kind of problem can only be done with a calculator. And that's exactly what they tell you. That's why I never mind if people use technology, because most problems you just have no choice but go with a arc cosine, return back to main. Please notice it's not really that long, right? And there you have it. When you say, what if I want to know in terms of degrees? Well, look at that. It's just 28 degrees. So what does it tell us? You see that? 28 degrees. It's really something that is not very common. Plus, we usually want to put the answers in terms of radians. So you just put the answers 0.505 dot dot dot. So that'd be the result. So again, most problems, I guess, are to be done using calculator anyways. So let's see what else is here. We have another group of problems that has these inverse structures. Remember, last time we did some of those with function arc sine. So now I can take its friend arc cosine for a change, and then just apply one to the other. And again, there were a few places to watch out, because they need to be inside the range. So if I look at 37, then everything will be fine with it. What does that mean? Well, let's write it. Arc cosine applying to cosine. So since they're inverse functions, then this 4 pi over 5, well, should be untouched. So it should automatically be the answer. But turns out not really, because of the restriction of the arc cosine range. 4 pi over 5 is fine. It's someplace here within the range, and that's great. But what if I take something, let's say, negative, like we have here in exercise number 42? What kind of angle should I have here? So take an arc cosine of negative 5 pi over 3. The answer is not going to be negative 5 pi over 3. So not negative 5 pi over 3. I need to get my favorite picture of unit circle and see what happens with this cosine of 5 pi over 3 with a negative result. So I need to, of course, draw this angle. So if I start with pi over 3, looks like we're gonna get here, right? So if I go like that, clockwise, this will be negative 5 pi over 3. But again, we need to have coterminal angle, which is going to start at 0 and go counterclockwise, and this is pi over 3. So this angle, and the answer will be actually pi over 3. Because again, it must be within the range, so pi over 3 will be probably, this is pi over 2 in the middle, so a little less than that, pi over 3. It must be in between 0 and pi. It has to be positive. And they gave us on purpose something negative. So it is just pi divided by 3. I say, can I check it with a calculator? Well, we can try. We can always try. Calculator is always here. I hope you all have access to this calculator by now, but I can still share it with everyone. I put it in the chat. I guess this is a nice tool. And since I'm using it, I'm sure you will eventually get used to it as well. So anyways, I need to get a arc function, arc cosine, which is here, right? So now I need to return back to the main menu. I say, here's cosine right above it. Okay, you can put a cosine from here, but you still want to return back to the main menu and put that 4 pi over, well, actually, negative 5 pi over 3. And see what will come out. 5 divided by 3. And please notice something positive is coming out. So that minus 5 pi over 3 is indeed not your answer. Please notice that it doesn't really give us this nice result for some reason. And I think that's something that is related to our calculator, because it doesn't give you correct number of degrees. And I'm not sure why, but if you go back to the radians, because that's how actually all of these exercises are being done in terms of the radians, and compare it with pi over 3 that we decided the answer was, then indeed you're going to get the same exact result. I'm not sure why this calculator is not given correct results in terms of degrees for this kind of exercises. And that's why I'm telling that you, well, cannot completely rely on it. Maybe you will find some calculator a little more advanced, but I think that's, well, something that whoever produced that calculator needs to work on. So pi over 3 is fine, you get the same answer, but with the degrees, which is what, 60, it has to give us 60 degrees, which is pi over 3, right? But it gives us like 5 something, so I'm not sure what is going on, because this is definitely not correct result. So keep in radians, we're on the safe side. So I guess you can do, I can do one more exercise for you, and then I want to say a few words about coming midterm exam. It turns out that next week, we're going to have a midterm, and this midterm will be something that I going to email to you a little later. So I will be sending you the recording of this lecture, and I will also send you practice midterm exam. So check your email sometime tomorrow, and then we're gonna discuss that together next time. So let me try another exercise like number 46, for example, from the next group. And it turns out for exercise like 46, that minus 2/3 is going to be the answer right away, simply because we have a negative 2/3. Well, say, now, Alex, you just said negative was not possible. You turned to positive. Well, look at what function you had. You used to have arc cosine of cosine, but now it's a cosine of arc cosine. So it's vice versa. And for the arc cosine, negative 2/3 is fine because that's its graph, and negative 2/3 is someplace here. So it is within your domain. See, domain and range. So we have fine number minus 2/3. The number that wouldn't work would be in 49 because the number cannot be outside of domain. It's 1.2 that is having undefined function. And I believe that last time I was showing it to you, you could just put this in a calculator and it'll tell you it's not defined. So anyways, so far we went through chapter 6 and also section 7.1. And I guess that's what you should work on for the homework. And our midterm exam will be next Tuesday, a week from today. And the homework will be due on that day. So what you can do is check out that YouTube channel if you did not start the homework yet. All lectures are there. If you need the access to it, I send it to you. I can show it to you again, of course. So do a couple of problems from each lecture. Let me say, what does that mean? A couple, is that 3? Well, 2 would be enough. Let's say you've done one, you've done the other. Good for this lecture, go to the previous, and so forth. So 2 problems from each lecture would be enough. If you want to do more, it's fine. I'm being pretty formal about homework. You do something, you make picture, you email me those pictures. I'm getting so extremely happy, I give you full credit. So I think it's pretty straightforward to get full credit for the homework because I always give full credit for homework. I just want you to practice outside of class. That's the key point. So yeah, I will, of course, try to find this YouTube link that I emailed to you a few days ago. You can also check the emails from me that I sent. So how you find emails, I click on send and then I look for 135. So this way I can always find, or you can just type my emails as a Alex, and it should be appearing pretty soon. So let's see, here it is, YouTube. So 135, so I can click on that link. And when you clicking on that link, then you should be a little bit patient, because I think that first lecture took a little time to start, right? So you're welcome. So I'm going to put this in the chat right now. I just want to clean this message. There's too much of it. So you can see that it's updated. It used to have only 6, I believe, and now there are 10 of them. So everything except for today's lecture, well, because today's lecture is just done. I did it early in the morning. So you can see there's a 10. So they're all here. They pretty much arranged, just 5 switched with 6, but I'm sure you'll be able to figure that out. So lecture 10 is what we had last time. It was 7.1. So these lectures are covering chapter 6 and chapter 7. So that's pretty much all you need here. So let me put this link again in the chat so you can click on that link. And then once it opens, save it. So here's the link for you. So after you click on it, remember this star? So that's how it's being saved to your device. And this way you can always have access to it. And in a few weeks, I will add some more lectures after we have some more of them. And that's, I guess, the way to go. So for the homework again, from each section of chapter 6, and then from section 7.1, you can submit a couple of exercises, 2 problems, be good enough. Yes. So when can you send them to me? Anytime. Remember, I was asking not to send me homework early because I didn't know what sections be covered exactly prior to this midterm. So now we know. So that's why I'm telling you, look at these sections. So whenever you're done with them, maybe you already have them, those exercises if you practice. Don't just make me pictures or scans, or some people put it on cloud and share a link with me. So far I was able to successfully open whatever emails my students sent to me, never had any problems. And that's why all you need is just do same problems and send them to me. Some people like to do not the same problems. That's also fine. Whichever ones you do for your practice, even if they may not be solved correctly, I will still accept for a full credit. Because again, my goal is just make sure that you practiced with these sections, and that's about it. So for the midterm, I'm going to send you a little later practice. There'll be just 2 problems. I don't put lots of questions in the midterm. I think I already told you. I usually put 2 problems. First problem and the second problem. And that's it. So this way, you're going to have plenty of time to do midterm. And I will give you a whole day next Tuesday. I'm going to send it to you first thing in the morning, and then you can work on it for as long as you like. And if I don't get your work on Wednesday, next day, I will email you a reminder email. Sometimes people get a reminder email from me even though they send their work, simply because I didn't receive it. Because with emails, sometimes things happen. Sometimes you forget to click send, or sometimes your file is too big, got corrupted, or sometimes, which usually happens, people don't wait long enough for the whole thing to be attached. So I think it's a good practice to send emails with attachments. So you need to wait, because sometimes a picture is very big and internet signal is pretty low, so it might be still attaching, and if you click send anyways, well, I will get empty emails. I'm not going to get that attachment. So usually that's the case. And that's why please check your emails next day after the midterm, which is going to be next week, Tuesday. So you check it on Wednesday. Make sure that I did not send you a question like, please send me your midterm or send it again. Something didn't open. So because things happen, and I never downgrade anyone because of that. I can always wait another day. That's fine. But my goal will be to grade it the following day on Wednesday and to update your grades on Canvas so you will know right away what you got on that little 2-question test, which I'm going to again send to you later today. And then Thursday, we're going to work on it together. Thursday be another class meeting this week, right? So we're going to discuss midterm in very detail. So you will know for sure what exactly on that exam. So when you receive email from me next week, Tuesday, you will see same exercises, just a little different numbers. So I'm sure you're not going to have any problems doing it. But I will be, of course, logged into Zoom next Tuesday at 2 o'clock. So if anyone has any questions, you can always ask because I will be there if something is unclear. Of course, I cannot solve the exercise for you, but I can, if something needs to be clarified, I'll be there. So don't worry about that. So I will wait for that midterm. We're going to talk more about it on Thursday. And then also homework. So whenever you're done with it, just send it to me. If you need more time, it's fine. I can give you more time. But it'd be nice if you could finish up before the day of a midterm. Because what's the point to do homework after the midterm? Because you're studying for the midterm. So try for the next Tuesday. Well, if something happens, you need more time, it's fine. I can always give you a little more time. It's not a problem. So I guess that's pretty much all I wanted to say today. So you can see that these recordings, I hope, are pretty clear. I just put it on the mute so you can always unmute them. And if you have any questions, please let me know. And if not, then you can start to put your homework together. So I will let you enjoy the rest of the Tuesday. I'm not going to give you a quiz today. I want you to just start to do homework, or maybe you're already done. So find them. So this way you will get that. So this lecture will be emailed to you. So check your email. I will email it to you. I just spent all night pretty much putting that stuff on YouTube. So I will put this lecture on YouTube, but maybe a little later. But you will get the same thing by email. So the AVC email, so just check it. It will be there. So yes, you make pictures of your homework, or you scan it, or whichever way, and just send me the homework. It may not be just one piece. You may need to send me 2 emails or 3 emails. Some people do lots of homework, so those pictures don't fit in one email. If you attach 20 attachments, 20 pictures, that email will be too heavy, so it's not going to go through. But 2, 3 emails, that's fine, and that's usually working.